Separation techniques are essential in chemistry and various scientific fields for isolating and purifying components from mixtures. There are several standard separation techniques, each suited to specific types of mixtures and components. Here are some common separation techniques and brief explanations of how they work. Filtration. Description. Filtration separates solid particles from a liquid or gas by passing the mixture through a porous medium, filter paper, mesh or a sieve. The solid particles are retained on the filter, while the liquid or gas passes through. Application. Used to separate suspended solids from liquids, such as in coffee brewing or wastewater treatment. Distillation. Description. Distillation separates components in a liquid mixture based on differences in their boiling points. The mixture is heated to vaporize the more volatile component, which is then condensed back into a liquid. Application. Commonly used to separate and purify liquids, like alcohol distillation in the production of alcoholic beverages or separation of petroleum fractions. Chromatography. Description. Chromatography separates components in a mixture based on their differential affinities for a stationary phase and a mobile phase. The mixture is passed through a column or paper, and components move at different rates, leading to separation. Application. Widely used in analytical chemistry for separating and analyzing complex mixtures, such as in gas chromatography and liquid chromatography. Centrifugation. Description. Centrifugation separates components in a mixture based on differences in their density or size. The mixture is spun at high speeds in a centrifuge, causing the heavier or larger particles to settle at the bottom. Application. Used for separating solid particles from liquids, as in blood centrifugation or the separation of cell organelles in biology. Extraction. Description. Extraction separates components based on differences in their solubility into immiscible phases, typically a solvent and a mixture. The desired component is transferred from one phase to another. Application. Commonly used in organic chemistry for isolating compounds from natural sources or complex mixtures. Crystallization. Description. Crystallization separates components by inducing the formation of solid crystals from a supersaturated solution. The desired component crystallizes out, leaving impurities in the solution. Application. Used in the purification of solid compounds, such as in the production of table salt or pharmaceuticals. Electrophoresis. Description. Electrophoresis separates charged molecules, typically proteins or nucleic acids, based on their mobility in an electric field. The molecules move through a gel or solution under the influence of the electric charge. Application. Widely used in molecular biology and biochemistry for separating and analyzing DNA, RNA, and proteins. Magnetic separation. Description. Magnetic separation separates magnetic materials from non-magnetic materials using magnets or magnetic fields. Magnetic particles are attracted to the magnetic source and separated from the rest of the mixture. Application. Used in industries such as mining to separate valuable minerals from non-magnetic impurities.
The first 20 elements. Hydrogen, H, mass number 1. Helium, He, mass number 4. Lithium, Li, mass number 7. Beryllium, B, mass number 9. Boron, B, mass number 11. Carbon, C, mass number 12. Nitrogen, N, mass number 14. Oxygen, O, mass number 16. Fluorine, F, mass number 19. Neon, Ne, mass number 20. Sodium, Na, mass number 23. Magnesium, Mg, mass number 24. Aluminum, Al, mass number 27. Silicon, C, mass number 28. Phosphorus, P, mass number 31. Sulfur, S, mass number 32. Chlorine, Cl, mass number 35.5. Note, it's not a whole number because it has multiple stable isotopes. Argon, R, mass number 40. Potassium, K, mass number 39. Note, potassium has multiple isotopes, but the most common one has a mass number of 39. Calcium, Ca, mass number 40. Note, like potassium, calcium has multiple isotopes, but the most common one has a mass number of 40.